Okay, so now we're going to jump into the fun and fascinating world of polynomial division. I know, that is exciting. I'm excited, you're excited, we're all excited. Let's get going. So first, we're going to start off with dividing by a monomial, because this is kind of its own little case or scenario, and we want to make sure we understand this when it arises. So first we need to think about what is a monomial. So when we say polynomial, that's just a generic term for, or not generic, it represents, well, all polynomials, I guess. So that was not a great explanation. But anyway, depending on how many terms we have, that breaks down polynomials into some specific names. So for instance, monomial is a polynomial with one term. Binomial, which you have heard me say many times, is a polynomial with two terms. Trinomial, which we have also talked about, is a polynomial with three terms. Those are really the specific ones that we talk about a lot. After that, we just call them all polynomials, but they are still all polynomials. However, specifically here, we're talking about a monomial. So a polynomial with one term. Remember, terms are just groups of numbers and variables separated by addition or subtraction. So how can we divide a polynomial by a monomial? Great question. Glad you asked. Let's get to it. So the nice thing is, if we're dividing a polynomial by a monomial, so we can see here, this is one term, this is one term. First, I'm just going to rewrite this, and I'm going to rewrite it just so that we can see it a little better. Remember that this notation is the same thing as x to the third. Sorry, that's really sloppy. Third plus x squared minus 2x all over x. So the reason why I rewrote it like this is because this helps us understand better the process. So whenever we divide any polynomial by any other polynomial, and it doesn't even have to be polynomials, this is just true in general, and the numerator has addition or subtraction in it, then what this is literally saying is each one of these terms in the numerator is divided by the denominator. And so that is the process that I'm going to use whenever I'm dividing by a monomial. So I can separate this into x to the third over x plus x squared over x minus 2x over x. Now let's focus on just one part of this real quick to make sure that we understand. So I'm going to focus on this right here. The reason I'm going to focus on that, whoops, don't want that, is so we had x to the third over x. And there's two things we need to remember here, or two possible ways we can think of this, I should say. So one is that anytime I have division of the same base, so remember when I say the same base, this is the base and this is the base, those are the same. Anytime I have division of the same base, I subtract the exponents. So this is the same as x to the a minus b. So in this case, remember, although this is not written here, this is x to the first. So I know when I divide these, this becomes x squared because 3 minus 1 is 2. The other way to think about this, if you don't remember that, is I could also think of this as x times x times x over x, because x times x times x is x to the third. And so if I think about it this way, then that helps me remember that, well, in this case, I can just cancel this x with this x, and I'm left with x squared. The point is, either way, we end up with x squared, whether you remember it as, well, x to the third is x times x times x, and so one of these x's reduces with the x in the bottom, or whether you remember that anytime I divide the bases, I subtract the exponents. Either way, we want to end up with x to the second from this result. Okay, so that helps us understand our process here, that x to the third over x, this becomes x squared over x becomes just x to the first, and here 2x over x, the x's cancel, and I'm left with minus 2. So my division is x squared plus x minus 2. Okay, let's do the next one. I'm going to go through this a little bit quicker. First, I'm just going to rewrite this. And so now when I split this up, 24x to the third over 6x minus 3x over 6x plus 12 over 6x. What happens? What's 24 over 6? 24 divided by 6 is 4. X to the third over x is x squared. Here the x's cancel. 3 over 6 is 1 over 2. Here 12 over 6 is 2, and there's no x in the numerator, so the x just stays in the denominator. So I get 4x squared minus 1/2 plus 2 over x. Okay, I want you to try the next two on your own. So pause the video, try and divide A, and then try and divide B. Unpause when you're ready to discuss. All right, so for A, hopefully you ended up with 3x to the third plus 7 minus 6 over x. How do we get that, just in case we didn't get that? So again, first I just rewrote this, and then I split up the fraction because I'm dividing by a monomial. So we can only do this because we're dividing by a monomial. If we're dividing by anything else, this becomes more complicated, and it's not, well, it's just not as straightforward, basically. So 3x to the fifth over x squared, x to the fifth over x squared is x to the third. Remember here I'm just subtracting the exponents, 5 minus 2 is 3, and then the 3 here just stays. 7x squared over x squared, those just reduce, and I'm left with just the 7. Here's 6x over x squared, so in this case I have 1x in the numerator and 2x's in the denominator, so when I reduce these I'm left still with 1x in the denominator. The 6 just stays in the numerator. For B, again, I rewrote it, split up the fraction here in the green. 2x to the fourth over 3x, the 2 over 3 just stays because those numbers do not actually combine or reduce, but x to the fourth over x is x to the third. Here, 9x squared over 3x, well, 9 divided by 3 is 3, x squared over x is just x. So it's a coincidence, but 9x squared over 3x is just 3x. And here, 3x over 3x, the 3 reduces, 3 over 3 is 1, x over x is 1, so I'm left with just plus 1. Now, don't forget that it is plus 1, and it doesn't just go away and become 0 or something. Okay, so just to wrap up, making sure we understand that when dividing a polynomial by a monomial, divide each term in the polynomial by the monomial. It's really important that we are only dividing by a monomial. Nice work.